Yeah. So, good evening, guys. Right. Okay. So, welcome you all. We'll just wait for another 2 minutes. Then we can see like when everyone is going to join. Then we can. Right. Okay. We'll wait for another 2 minutes. Don't happen like students are not joined. Right. So, guys, good evening once again. I don't know why the strength is a bit low. We'll just see for 1 minute. Then we can start 5-2. Then we'll start at 5-4. Okay, on 2 minutes. Then we will start. So till then, you just tell me whether I am audible and my screen is visible or not. Please let me know through the chat box. Come on. Come on, guys. Please do. No one has been joined till now. Okay. So guys, I don't know why no one has joined. Let me check with everyone. Right. I don't think so. What happened? What is the issue? I didn't get, but till now, no student has been joined. Okay. So it's already 5-5. I don't want to waste time as it is a YT live recording. In case if you missed anything, you can go through the YouTube and you can check this. Okay, guys. My name is Gopi Chand. I am your presently basics, chemistry teacher, which I'm going to cover your basics from periodic table and then chemical bonding. So later on, you are going to assign with a new teacher. And now, as far as examination is concerned, you are going to have your unit test. And I know the weather is pretty cool out there, and it's raining here in Bangalore. So probably, you all guys might have been having a happy Saturday, second Saturday, parents have might have came. You might be busy in all your events and all, but still okay. We will try our level best to cover the things in the best time possible. Okay, right. So this is the index of the today's class. I'm going to cover you some of the, not today, overall the periodic table. We're going to talk about the various types of periodic table and the important topics, basically, know what are the S block, P block, D block elements, how to recognize the elements, how to remember the elements, how to write the electronic configuration. All these things are going to be discussed in this particular classes. Okay. So basically my aim is not to talk about theory much. It's about the competitive oriented KCET and JEE and NEET, and for the CBSE also important concepts. And what are the various types of periodic table, Darwinius, Newland, Lothar-Meyer, and Mendeleev's. And okay, I'm give the glimpse of those things, but I don't want to discuss deep about them. Nomenclature above 100, so how we are going to name them as there is a different designation has been given to them. Abbreviations will be given. Usually in your JEE mains, NEET exams, and KCET also, they are asking the questions of it. And some of the definitions like effective nuclear charge, diagonal relationship, screening effect, inert pair effect, and oxidation state, how to find and everything and all. We're going to study about those things. Okay. So guys, there is a power cut issue was there. If you are unable to see me, please bear me for some time. Okay. Now some of the exceptions we are going to discuss. So basically periodic table is all about exceptions. If you see there is exception in ionization enthalpy, in electron affinity and electronegativity. Okay, so the exceptions basically you have to know these exceptions and which you are going to get in your examinations. Okay, so now moving on. First we are discussing about Dauvergne triads. So basically Dauvergne triad, the name suggesting it's a triad. Triad means consisting of three. So Dauvergne triads has been, Dauvergne is a scientist, he given a periodic table in the form of a triads. What is the meaning of a triad as per Dauvergne is there are three elements in a particular group or period, whatever it may be. He didn't mention their group or period. We can say certain set. Okay. If I'm saying these are the period, it consists of three elements. And he's saying first, second, three. So the average of the first and third element will be the middle element atomic weight. So the average weight of the first element and the third element is the middle element atomic weights. So Dauvergne postulated, or we can say given the periodic table based on the atomic mass, or we can say atomic weight. I hope you guys are clear with this. Next, some of the physical and chemical properties are also resemblance. So these are the four important triads which you will observe in your examination. They will ask which among the following is Dauvergne triads. So you can clearly say that iron, cobalt, nickel, lithium, sodium, potassium, chlorine, bromine, iodine, calcium, strontium, and barium. So you just people need to remember these triads. Nothing much, nothing short. Next one is Newland octaves. So Newland actives, or we can say that Newland laws of octaves. He also formulated the periodic table based upon the atomic weights. So we can clearly say that atomic weights increases. Okay, so the element has been, or we can say the periodic table as per the Newlands has been formulated in the form of a octaves. What is the meaning of octaves? Octaves are simply nothing but sarigamapa. Sarigamapa. Okay, so every eighth element has been same. If you check that one. So the tune of every eighth element as a note or music note is should be same. So simultaneously, what are the properties of the lithium and sodium and potassium? These three are having same properties, and these table is also formulated based on the atomic weight. Very, very most important. Okay, guys. Next. Yeah. So next, if you see, but it has been valid only up to calcium. Next, Mendeleev. Very, very most important thing is Mendeleev, and these Mendeleev has been tried to give the periodic table in a proper way. He found 63 elements. Okay, and he mentioned around 8 groups, whereas in modern periodic table we are having 18 groups. But as per the Mendeleev, he formulated 8 groups. Okay, and he predicted the position of unknown elements also. So at that time, gallium, scandium, germanium, and technetium has not been discovered, but still he predicted and he made a box, he made a table, and he left the blank spaces for the prediction of other elements. So he predicted the whatever the elements which you are going to found in the future need to be placed in the particular groups or in the particular periods. He mentioned like that. Means Eka aluminum is simply nothing but gallium, Eka boron is scandium, Eka silicon, germanium, Eka manganese, technetium. So these are the elements where has been, not discovered at that time, but still he mentioned in the name of Eka aluminum and Eka boron and Eka silicon and Eka manganese. Okay. Admin, can which school it is? Can unmute and tell me which school? I don't know what is that. Right, Eka aluminum, Eka silicon, and Eka boron. Okay, Eka aluminum, Eka silicon, Eka manganese. So in your JEE mains exam, NEET exam, KCET exam, these are people are asking on questions on these four things. Okay, I hope you guys are clear with what I'm saying. Right. Next, so some of the drawbacks we need to know from the Mendeleev periodic table. That's very, very most important. Prediction of hydrogen. So they mention hydrogen position they kept in one first period. But interesting fact is this is having a properties of halogens also. So the position of hydrogen is critical by the Mendeleev. So he didn't given a proper explanation for the position of hydrogen. That is one drawback. And we can say that position of isotopes, whereas in modern periodic table, the isotopes has been placed along with the main element, but at that time, Mendeleev didn't talk about position of the isotopes. And some of the elements has been wrongly placed. Let's suppose if you see tellurium and iodine, it is 127 and it is 126, but it has been kept first, but it has been kept second. But here he didn't given any proper explanation. He said that thallium and iodine is both are having same physical property, so that's why I'm keeping there. But he forgot that on what basis he formulated the periodic table. He formulated the periodic table based upon the atomic weight, but he ignored the significance of the atomic weight, but he focused on the chemical properties, but he didn't given the reason for it. Okay, so some of the elements I've kept before. Okay, this one, right? Okay, guys. So just a minute. Okay, so basically what happened, like majorly the Mendeleev periodic table has been formulated based upon the atomic mass, based upon the atomic mass. So pretty clear and very, very most important. Okay, next one. Yeah, just now I told you tellurium has been placed first and simultaneously cobalt and nickel. So even though their atomic mass is less, still they have kept on the prior one, not as a uh, not as per the order. So to face these drawbacks or to give the proper explanation or to give the significance of the modern periodic table, there is a scientist called Mosley who tried to give the formulation of modern periodic table. What is the meaning of modern periodic table? That is the periodic table which we are using now. So the periodic table which we are using now has been first tried to give as an experiment evidence by Mosley. So what Mosley is suggesting that he taken certain elements and he passed X-rays over it. I mean, like he passed X-rays and he got to know that whatever the frequency of the elements, okay, that is directly proportional to the atomic number. Okay, so he given based upon that the equation, which is also called as Mosley's equation. Very, very most important, guys. In your NEET and KCET JEE exam, this Mosley's diagram, Mosley's equation has been given, which is, in the on the basis of the experiment, what we got to know, the all the elements we don't know, like he taken certain metals like sodium, magnesium, potassium, all these elements, he passed the X-rays on the metals. So After that, there are some radiations has been emitted here. There has some radiations has been emitted. I'm so sorry, guys. There is power gone, so you may not see me well. Yeah. So we can clearly say from this one is there are emitting certain radiations after passing the X-rays. These radiations will have certain frequency, and the frequency under root is directly proportional to the Z, which is atomic number. So now the scientist has been formulated based upon the atomic number, not with atomic mass. Okay, so this is the when they have formulated with atomic mass, they have seen some steeps and slopes. They have seen some up and downs with respect to atomic mass. But whereas when they see with respect to the atomic number, they see a clear increase. They see a clear increase in the graph, which indicates that the atomic numbers or the periodic table has been formulated based upon the increasing order of their atomic elements. Increasing order of their atomic elements. So very, very most important. Okay, guys. Yeah. So totally, this is the formulation for the modern periodic table. So these are the outlines of the modern periodic table. So based upon the modern periodic table, we on the electronic configuration, we got to know there are 18 columns which are called as groups and 7 rows which we are called them as periods. And total we are having 118 elements. Total we are having 118 elements, but these are not a fixed number. Again, the number of elements are going to invite now. So we can't say there 118 is a fixed element. Till now we found 118 elements. Okay. I don't want to discuss much theory about here. So let deeply dive into the tips and tricks. So this is how the modern periodic table looks. Now, let me talk about some of the important things here. You can clearly say there are some yellow indications. Okay, there are some yellow indication of the metals. These yellow colored indication of the metals are called as metalloids. What are metalloids? Metalloids will show the properties of both metals and the non-metals, or we can also say that semi-metals. We can also call them as semi-metals or metalloids. So their position has been fixed between metals and non-metals. So how to remember the non-metals or how to remember the metals? You can simply, by practicing. So for all the alkali and alkali earth metals, that is S block elements are usually metals, and P block elements mixture of metals plus non-metals plus metalloids. So we know non-metals are simply nothing but gases. Okay, metals are there, aluminum like that was there, but still for your purpose of remembering, तेरे गीत सबसे भासी और आसान. So just this is the trick, guys, to remember what are metalloids. What is the trick? तेरे गीत सबसे भासी और आसान. So बहुत अच्छा है. Or like the whatever the song that you are singing, that is very good and it's a like easy one. Okay, so that's what you can say, that tellurium, okay, germanium, antimony, okay, selenium, bismuth, silicon, and arsenic. So these are the metalloids, even if you can see here. Okay, these are the metalloids. Okay, so you can clearly remember this one, right? Now, these are the very, very most important, how to identify a period, how to identify a group, how to identify a block. Okay, we will discuss this one later. Just focus here. Yeah. So the atomic number can be found out by the number of electrons in the neutral atom or the number of protons. Let's suppose if I'm saying the atomic number is 6. So how many protons will be there? The number of protons will be 6. Okay, if the atomic number is, and how many electrons will be there? The electrons is also 6. Okay, if I am saying the atomic number is 12, if the atomic number is 12, how many protons will be there? 12 protons. Okay, how many electrons will be there? 12 electrons. Okay, let's suppose if I am giving you Na, Na is atomic number is 11, so the number of proton will become 11. If I am giving Na plus, the atomic number is 11, but the protons are 11, new electrons will become what? 10, because plus symbol indicates we have to remove one electron. You have to remove one electron. So ideally, atomic number can be decided or can be also gives the significance of number of electrons in the neutral atom, okay, and the number of protons. Now, atomic number is related to the quantum number and electronic configuration. Okay, so that's why the periodic law is the consequence of periodic variation of the electronic configuration. Okay, so no need to remember all these things and all, but just remember how many periods are there. Total 7 periods and 18 groups are there. That you need to remember. So periods, the principal quantum number, the highest principal quantum number, that is fixed. Okay, so if you want to know, if I am telling you that n is equal to 3, so n is equal to 3 if I am giving you, that means it belongs to which period? Third period. If I am telling n is equal to 4, so which period these particular n value becomes? Third, fourth period. So based upon the principal quantum number, okay, we can clearly say that periods can be determined. And based upon the valence shell electronic configuration, or we can say outer electronic configurations, will give the significance of groups. So period number can be given by quantum number, and outer electronic configuration will be given by valence shell. Now, some of the important tricks to remember the periodic table. Very, very most important, guys. Very, very most important. Everyone pay attention here. Yeah. So very, very most important, guys. Everyone pay attention here. Helena ka ruby friend. What is the trick to remember 1A metals? 1A metals का trick क्या है? Helena का ruby close friend. Okay, Helena का ruby close friend. Next, बेटा मांगे कार स्कूटर बाप राजी. बेटा मांगे means asking, car scooter, baap means father, raji means son is asking car and scooter, father accept. Is it really exist? Is it really true in our real life? Yeah, Ambani family will be there, but in our families it's not easy. Asking both car and scooter, and father is accepting. That's a joke. Okay, so that's why don't do like this at your home. Don't try at home. Next one, we are talking. These are group 2 elements, and we know group 1A elements is called as alkali metals. Alkali metals, and group 2A are called as what? Alkali earth metals. What is that? Alkali earth metals. I hope you guys are clear. Alkali earth metals. Right. Now, alkali earth metals. Now we are going to talk about 13th group. 13th group. Very, very most important. Remember 13th group. Bala Ganesh in Thailand. What is that? Bala Ganesh. Group 13 का trick क्या है? Bala Ganesh. Okay, Bala Ganesh. Bala means B, Ala means aluminium, boron aluminium, Ganesh in Thailand. So that is in means indium, Thailand means thallium, Ganesh means gallium, Bala means boron and aluminium. I hope you guys understand. Bala Ganesh in Thailand. Guys, do you like the trick? Please let me know through the chat box. If you like the trick, please let me know through the chat box. Come on, guys. If you like the trick, please let me know through the chat box. Palaganesh in Thailand. Next, group 14th. Group 14th. This is a bit Kannada version. I don't know like whether you people will like it or not. Chemistry, sir, gay sneezing problem. Chemistry, sir, gay sneezing problem. Ge means in Kannada, that is having means. Okay. Our chemistry sir, Geetam Raj. Okay, just you can remember. Chemistry sir, Geetam Raj, having what problem? Sneezing problem. Chemistry sir, Geetam Raj, having sneezing problem. Chemistry sir, Geetam, having what problem? Sneezing problem. Sneezing means SN, problem means PB. Geetam means germanium. Silicon means, sir means silicon. Chemistry means carbon. Okay, I hope you guys can remember this one. Next, New Zealand, Pakistan, Australia सब बिक चुका है. न्यूजीलैंड, पाकिस्तान, ऑस्ट्रेलिया सब बिक चुका है. मीन्स ऑल न्यूजीलैंड, पाकिस्तान, ऑस्ट्रेलिया सब बिक चुका है. Big Chuka means what? They have been sold out during the IPL match. Okay. New Zealand, Pakistan, Australia players sub Big Chuka hai during IPL auction. Okay, guys, I think you people can remember. Oxygen, sulfur, silurium, tellurium, polonium. ये कैसा रिमेंबर कर सकता है? हो साइंस से तेरे को प्रॉब्लम है. वो साइंस से तेरे को प्रॉब्लम है. You can remember this one. Next one, father, collector, brother, inspector, attention. Very, very most important. Father, collector, brother, inspector, attention. Next one, neon, argon, krypton, xenon, and radon. Neon, argon, krypton, xenon, and radon. These are the periodic table elements. Okay, I hope you guys are understand this one, right? Again, I will repeat the trick. I'll change the color and I will repeat the trick. Please focus once again. Again, I'm repeating, taking time and repeating, guys. Understand me. Right. Now listen carefully. What is the first trick? Helena ka Ruby close friend. First one is what? Helena ka Ruby close friend. First one, that is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. This is first one. Next one, beta mange car, scooter, Bob, Raji. Beta mange car, scooter, Bob, Raji. Okay. Next, boron, aluminum, gallium, indium, and thallium. Bala Ganesh in Thailand. What about this one? Chemistry sir, Geetam, having sneezing problem. Chemistry sir, Geetam, having what? Sneezing problem. Next, nitrogen, phosphorus, arsenic, antimony, bismuth. Okay. New Zealand, Pakistan, Australia सब बिक चुका है. किसमें बिक चुका है? IPL में बिक चुका है. So New Zealand, Pakistan, Australia सब बिक चुका है. Or else you can also remember like this. Nana Patekar, Aishwarya sab bindas. Nana Patekar, Aishwarya sab bindas. Like that also you can remember. हो साइंस से तेरे को प्रॉब्लम है. हो means oxygen, science means sulfur, say means with that subject, तेरे को means you having problem. Science से तेरे को problem है. So that is oxygen, sulfur, silurium, tellurium, and polonium. Next, fluorine, chlorine, bromine, iodine, and atomium. That is father, collector, brother, inspector, attention. Okay, I hope you guys can remember these elements. Okay, so again I'm going to write here Helena का रूबी क्लोज फ्रेंड है. बेटा मांगे कार स्कूटर, बाप राजी. नेक्स्ट वन, बोरान Aluminium, Balaganesh in Thailand. Next one, chemistry, Sir Geetam having sneezing problem. SN means tin, PB means lead. SN means what? Tin. PB means what? Lead. Very, very most important. Next one, New Zealand, Pakistan, ऑस्ट्रेलिया आईपीएल में सब बिक चुका है, सब बिक चुका है। हो साइंस से तेरे को प्रॉब्लम है, वो साइंस से तेरे को प्रॉब्लम है। नेक्स्ट, फादर कलेक्टर ब्रदर इंस्पेक्टर अटेंशन। नेक्स्ट, नियॉन आर्गन क्रिप्टॉन जीनॉन रेडॉन, इसके ऊपर हीलियम लिख दो, बस खत्म कहानी। आई होप यू गाइस अंडरस्टैंड हाउ टू रिमेंबर दीज एलिमेंट्स। ओके, how to remember these elements. I hope everyone understand. Okay, yes. Now next one, magic number trick. Next one is what? Magic number trick. Sir, what is the meaning of magic number trick? So magic number trick means I'm going to write the number of elements in the period. That's it, the number of elements in the period. First to second, third, fourth, fifth, sixth, seventh, eighth. Wow. When I'm writing eighth, you people don't agree. We are having only 7 periods. So first period consists of 2 elements, namely hydrogen and helium. Next 8, next 8, then 18, 18, 32, 32 plus. Still 7th period is incomplete, but still we consider it as having 32 elements. So this is the major magic number trick. This will gives you the number of it will gives you the number of elements, the number of elements in that period, number of elements in that period. Sir, after knowing this one, what I can do? Yes sir, I can understand. I got to know about this one. What I can do? Let's suppose, now going back to here, now going back to here, if I want to know the atomic number of tellurium, if I want to know the atomic number of tellurium, what is the atomic number of tellurium? Okay, and if you remember the trick 2, 8, 8, 18, 18, 32, 32, then you can easily remember. How, sir? Just see here, the atomic number of helium is 2. Okay, so now if you add plus 8 here, then this will become 10. For 10, you have to add how much? Again 8, then it will become 18. For 18, you need to add 18. So then this will become 36. For 36, you need to add 18. Then this will become 54. For 54, you need to add how much? 32. So which is nothing but what? 7, 87. This is becoming what? 87. Now this is 54. Then this will become 53. And this will become 52. So now you got to know the Z for tellurium is how much? 52. Very, very most important and easy. Then you can think of it. So you can find the atomic number of any element by using the magic trick. I hope you guys understand this one. I hope you guys understand this one. Please let me know through the chat box. JNV Mahe, JNV Rajkot, Ritik Arangle, admin team. Come on guys, respond something in the chat box. Respond something in the chat box. Right. Okay, so this is the magic number trick. Again, remember 2, 8, 8, 18, 18, 32, 32. Very, very most important. This is first period. This is second, third, up to 7 periods. Okay, 7th period. So in hypothetically one question I would like to ask. I will see how many people will tell. So now I'm giving you the homework. Remember, if orbital are accommodating, if orbitals are accommodating 3 electrons, now tell me how many elements are there in the period 2. How many elements are there in period 2? If the orbitals are accommodating 3 electrons, how many elements are there in what elements are there in second period. Second period में कितने elements होंगे if the orbital having 3 electrons? Usually orbital is having what? 2 electrons. But now ideally, hypothetically, if we are having 3 electrons, how many will be there? That is a hint. Trick will be this one. Trick will be this one. Okay, I hope everyone guys understand this one. Very, very most important. Next one. Let's suppose if I'm giving Z is equal to 112. I told you to write the electronic configuration. So whether you people remember it or not, molar diagram is there. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 6g. Very, very most important. Now, this particular diagram is called as molar diagram, or we can also say filling the electron in the increasing order of the electronic configuration. Okay, I hope everyone understand this one, right? I will change the color. Just a minute, I'll change the color so that it will be useful for you. Now, how to fill the electrons? I am drawing the road here. First, you will go through 1s, then you will go to 2s, then from 2s to 2p, then 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 5f, 6d. So like this, it is going to happen. Like this, it is going to happen. Okay. Now, I'm going to write the order here. 1s, 2s, 2p, 3s, 3p. Next one is what? Then 4s. Next, 3d. Then what is there? 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 5f, next one 6d, like that it will be there, 5g. Okay, next 5g, like that. Okay, sir, how do you return all these things? By the increasing order of n plus l value. So if you check any n plus l value, that should be formed like this. वो ऐसा form होना चाहिए. Okay. Okay, guys, just a minute. Let me keep my touch over here so that you guys can see me. Yeah. Okay. So now this is the order based upon the n plus l value. Now let me check for 1s and 2s, 2p. What are the n plus l values? N plus l value, n is equal to 1 and l is equal to 0. For s, I'm going to write here. For s, l is equal to 0. For p, l is equal to 1. For d, l is equal to 2. For f, l is equal to 3. So for n is equal to 1, l is equal to 0. This will become 1. And next, this will become what? 2, and this will become 3. So you can also see that filling of electron is taking place in the increasing order of energy. So this is the increasing order of energy. Increasing order of what? Increasing order of energy. Okay, so this is increasing order of energy. We need to fill the electrons. Now I told to fill 112 electrons. We know S can accommodate maximum 2 electrons, P can accommodate 6 electrons, D 10, F can accommodate 14 electrons. Okay, so these orbitals can accommodate how many electrons? 2, 6, 10, and 14. Okay, now let's see. We need to fill 112. So in S2, again 2, P6, total 10, 12, count it. 18, 20, 30, 38, 40, 50, 56, and next 58 plus 4. 58 plus 4, 14, how much? 72. 72 plus 10, 82, 82 plus 6, 88, 88 plus 14. 88 plus 14 is how much? 12, there's 102. 102 plus 10, 112. So this is, yeah, so like this you have to fill. So this is the order of electronic configuration. So if you are having a doubt, you can also write like this. So this is the electronic configuration. So for any element, you can find the electronic configuration by the molar diagram. I hope I have given a simple tricks. Now, I didn't discuss much about this. Simple tricks I am giving. By using the molar diagram, you can find the electronic configuration of any elements. Okay. So again, very, very most important, how to draw the molar diagram. Again, I'm writing 1s, 2s. For 1s, I'm writing, so that's why only 1s orbital. 2s, so that's why I need to write 2p. Next, 3s. So 3s means 3p and 3d. Next, 4s. 4 is coming, so that's why 4p, 4d, 4f. Next, 5s. 5 is coming, that is 5s, 5p, 5d, 5f, 5g. Next one, 6s is there, so that's why 6p, 6d, 6f, 6g. Okay, now again, how you need to go? First, you need to take 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 5f, 5. So I hope you guys understand how I am going this one. So this is molar diagram, which is helps to find the electronic configuration of any particular element. Okay, and another important thing, you can write for 1s2, 2s2, 2p6, you can simply write it as neon. Okay, for the argon also you can write, for krypton also you can write, for xenon 54 you can write, radon for 87 you can also write. So for the inorganic configuration, you can mention them. Best example, let's suppose sodium, if I am wanting to write, I used to write 1s2, 2s2, 2p6, 3s1. So now I am simply write helium and 3s1. I hope you guys understand. So both are same. Okay, very, very most important guys. यहाँ तक ठीक है, सबको समझ में आ गया होगा. Next. Yeah, so this is the long periodic table, and we are having S block elements. We are having 7 periods and 18 horizontal groups, and these are lanthanoids and actinoids. So lanthanoids from 57 to 71, 57 to 71, and actinoids are from 90 to 103. Actually, this is from 58 to, okay. This is not. These are present over here. Okay, galti se aa gaya. And 58 to 71, 90 to 103 are the lanthanoids and actinoids, and the combination of lanthanoids and actinoids is called as F block elements. These are P block elements, these are D block elements, these are S block. Very, very most important thing is S and P is called as representative elements. Representative, I will draw here. Yeah, so S and P are called as what? Representative elements. Representative elements. Okay, and D block elements are called as transition elements. Transition elements, because they always involve in the electron DD electron transition, and they are usually metals, and they are having high oxidation states. They can produce colors. They will have the magnetic properties. Okay, except यहाँ पर except लिख दो. Except zinc, cadmium, mercury, and IUPAC. So these 4 elements are not called as transition elements, even though they are D block elements. They are D block, but they are transition elements. Why such case, you may get the doubt. So that is the reason, because what is the reason? The reason because so the reason, because what is the reason, guys? So the reason is pretty simple. I don't know why today's power too many times it is going. Last 10 minutes, guys. I will turn off my video because the power was gone. I was unable to do this one. So I'm turning off my video. So sorry for that. right? So transition elements. What are transition elements? Which are having incomplete d electrons, in ground state or in common oxidation state. So zinc, cadmium, mercury, and this UUB, they violates the transition elements definition, but even though they are D block. Next, F block elements are called as inner transition elements. we'll we'll study them separately. Very most important. Now, very most important for S block elements, the general electronic configuration is NS122. For P block elements, the general electronic configuration is NS2 NP126. For D block elements, NS2 N-1 D1 to 10. And for F block elements, N-2F and N-1D and NS, okay, N-1 to 14 and N-1D 0 to 1 and NS 2, 1 to 2, the NS 1 to 2. These are the general electronic configuration of the F block, P block, D block, and S block elements. Okay, these you people need to know. I hope you guys can understand this one. Now, another last one for today's topic is how do you name, okay, the elements with greater than Z as an atomic number. JEE Mains, NEET, KCET, CBSE also, they are highly asking these questions from these particular concept. Okay, now, so how do you remember this one? So this is very simple. First, you need to know some abbreviations. So those abbreviations, why we need to know some abbreviation? Because after 100 elements, people are giving the names based upon their invention. Now, Soviets have given, Russian people have given for 104 as Kurchavitium, but Americans is saying because of Rutherford only it has been invented. So that's why we call them as Rutherfordium. So that is why, to avoid the conflict, for which name we can call them. In Russia, it is talking with other name. In China, it is with other name. In Australia, it is other name. So to avoid the confusions, we are having a common IUPAC naming by this particular Boolean algebra kind of method. So now here you can clearly say that, so whatever the digits are there, whatever the names are there and abbreviations are there, you just remember. Okay, and just add IUM at the end and add IUM at the end. Okay, guys. Now see very clearly. So the IUPAC name, let's suppose if I want to know for 101. So 1 is simply nothing but here, and it is called as un, and 0 is simply nothing but nil, and 1 again un-ium. So unnil-unium is what is that? That is 101. And iska shortcut kya hoga? Un means u, nil means n, and again un means 1. So unu is simply nothing but 101. I hope you guys understand the importance of the nomenclature more than 100. Okay, more than 100, how to name this one. So listen here very carefully. If you are 0, it is nil. For 1, it is un. And for 2, it is by. And for 3, it is for try. So sorry guys, because of the interruption caused. So now elements 101, that is un-nil unium, and UNU is 101. Next one, for 2 we call it as bi, and for 3 it is tri, for 4 it is quad, and for 5 pent, 6 hex, and hept, octant, and very most important, for 9 we call it as ENN. For 9 we call it as ENN. So many people will say that 9. So the ENN short form is E. 9 ka E is the short abbreviation. 0 short abbreviation is N. Don't confuse. 9 means N. 9 means NINE. So that's why N will come. No. This is wrong. For 0, we call it as nil. For 9, we call it as ENN. So for that point of view, you need to remember very, very most important thing is what? These are the abbreviations and these are the names. These are the digits. So if you remember, you can easily find it out. So let me give some examples. Let's suppose if I want to find for 112. 112 means what? 1 is un. Again, 1 is un. 2 means what? By. And last you need to add what? IUM. So that is unbm. Unbm. Shortcut from UUP. UUP. That is unbm. Okay. Next, let's suppose 109. 109 means what? 1 means U, 0 means N, 9 means E. UN is the short abbreviation. I hope you guys can remember it very easily. Right? So let me show you some of the other. For 112, 112, B. So that's why BM. So the sharp symbol will be UUP. Next, for 108, you see 108 and nil oct. 8 means oct, so that's why we call it nil octium. Nil octium. So that nil octium and the shortcut will become UN Uno. UN Uno. Okay. How many of you know about Uno game? Tell me. How many of you know about Uno game? Cards game, right? I thought of playing, but I thought it's out of my mind. So why I should play? Okay. Uno. Next. Yes. So these are the official names. Very, very most important. JEE Advanced they are asking. I'll tick some of them. You remember, and those are going to ask in your examination. Okay. Copernicium, Rontengium. Okay. Tennessine. This is one. Yeah, Nobelium. So these star marks has been asking in your examination. Okay, they are asking in your examination. So that's why very, very most important. Just remember only this one. Just remember, then you will automatically find in your examination. Okay. I hope you guys are clear with this. Okay. So blocks in the modern periodic table. Just now I told you S block, P block, D block, and F block. So again, F block we are having lanthanoids and actinoids. Okay. We are studying about S block elements. I already told you alkali metals and alkali earth metals. 1A are alkali metals, 2A are alkali earth metals. The general electronic configuration is 1s2. So except these, every element form ionic compound. Lithium and beryllium, they form covalent also, but except these two, others are always form ionic compounds. Metallic character down the group increases, reactivity increases because they immediately lose electrons very freely. So they are never found in a pure. Same P block elements. This is the general electronic configuration. Oxygens, we call them as chalcogens because they always exist in the form of oxides and sulfides in the earth crust. Nitrogen family, we call them as pnictogens. Nitrogen family, we call them as what? Pnictogens. Pnictogens means suffocating smell. Next, fluorine, bromine, we call them as halogens, means sea salt forming tendency, or we can also say metallic salt forming tendency. So that's why we call them as halogen family. Oxygen is chalcogens because they always exist ores in the form of oxides and sulfides. So the ores are always exist or together in the form of oxides and sulfides. So that's why we call them as this one. Okay, na? So they are always here. Okay, and usually non-metal and their reactivity is less compared. Okay, so these are the DBlock elements ka non-metallic character increases from left to right. These will for group 16 and 17, they can easily gain the electron to become stable. So they always form covalent bonds. Usually metals form ionic bonds and non-metals will form covalent bonds. They are having higher ionization enthalpy compared with right? ionization enthalpy increases, and their reducing character increases from top to bottom because they're ready to lose electrons. So reducing character is given by which is ready to lose electron. That is the strongest reducing character will be there. So metallic character increases down the group, and these highlighted one, these highlighted ones are what? These all are metalloids. These all are what? Metalloids. Okay, these all are metalloids. Okay, तेरे घी सबसे आसी और आसान. Okay, that one you can remember. Next, D-block elements are transition elements. So this is the general electron configuration, n-1 d 10 ns2. So this is the general electronic configuration, n-1 d 10 ns2. So they exhibit colored, they are having variable oxidation valency. They are usually paramagnetic in nature because that consists of more unpaired electrons and they act as catalysts. So all the D-block elements are transition elements, but except what? Zinc, cadmium, and UUP. Okay, zinc, cadmium, mercury also. These four are not called as transition elements because they are completely filled in their ground state and the common oxidation state also. So that is why these elements are not called as transition elements, but they are D-block elements. Okay, so these are called as same story for the lanthanoids and actinoids, which are inner transition elements, are also called as D-block elements. I told you the general electronic configuration is n-2 f1 to 14. Okay, very most important. And iske andar exceptions hai. Ask your school teachers. Okay, what are the exceptions? And यहाँ पर D-block में भी exceptions है. यहाँ पर भी exception है. For palladium is also exception. Try to find for that. Okay. Okay. So these are elements after uranium are called as trans-uranium elements. These are man-made elements. These are man-made elements. Okay. So classification of metals we have already seen. Okay, we will see in the next class. Okay, that's it, guys. Thank you so much for joining the class. Tomorrow class we are going to finish the periodic table. I'll give you the glimpse of it. Okay. Thank you, guys. Thank you for your time. I hope happy